In this video, we're going to be looking at part 2 of the review for chapter 1's test. We're going to start off with combination and composition functions. As you can see here, combination functions are where you add, subtract, multiply, divide functions. But in this case, I'm also asking you to plug in a number and evaluate. So after you combine the functions, you do need to plug in your actual value for x. So let's get started with 17 here. This one says you have to add f and g together. So I'm going to go ahead and add these two functions together. I'm going to use colors here so you know which function I'm referring to. So for the first one here, I'm going to take f, which is x squared plus 7. Now you might remember me harping on making sure you use parentheses when you add or when you combine functions. So this one's f, this one's g. I'm going to add them together by combining the like terms. In this case, only the 7 and the -2 can combine. So I'm just going to bring down everything else. I'll put them in order just to make it look pretty. 7 minus 2 is positive 5. And then once you have your function, you're just going to plug in the -4. So if I plug in -4 in for my x, let's see what we get. So -4 squared is 16. Plus -4 is going to be subtracting by 4. And so if I combine these numbers together, 16 minus 4 is 12, plus 5 is 17. So 17 is my answer. All right, let's check out the next problem. So this one is a subtraction problem. So I'm going to start by taking my f, which is the x squared plus 7. And I'm going to subtract it from my y, which is the x minus 2. And so when I have subtraction, it's really important to use parentheses or else you might forget to distribute that sign. So like I said, parentheses are important when you're doing combination functions. So in this case here, I would have x squared plus 7 minus 2 plus 2. And so I can combine the 7 and 2 together, bring down everything else. 7 plus 2 is 9. And so now I would just plug in my 8 in for x. So that would give me 8 squared minus 8 plus 9. 8 squared is 64 minus 8 plus 9. So I'm just going to add this up in a calculator. So 64 minus 8 plus 9 is going to give me 65. So I'm running out of room here, so I'm going to just put it on the side. And then this one here, you're multiplying. So again, you're going to take your f. So x squared plus 7 times my g. So notice that I'm combining first and trying to simplify and then trying to plug in. There's no right or wrong way to do it, but I find that this is easier for me to remember. X squared times x to the first power is x cubed. X squared times -2 is -2x squared. Positive 7x times -2. Oops, I don't know why I wrote parentheses there. So I've distributed the 7, got 7x minus 14. From there, I'm looking at my terms, but I don't think I can combine anything. So I'm going to go ahead and now plug in 6. So this is probably going to be a big number because I have to cube 6. And I have to square it. So if I cube 6, that's like 6 times 6 times 6. 216. If I take 6 squared, that's 36 times 2 is going to be, I believe 72. Yep. And 7 times 6 is 42 minus 14. So I'm going to add all of this up here. So 216 minus 72 plus 42 minus 14 is going to give me 172 as my final answer. And then this one here is division. So we're going to do f divided by g. So taking my f, which is x squared plus 7. Now in this case, I'm not going to use parentheses because the division bar is separating them already. So I don't need to use parentheses here. But it doesn't hurt. It's just a little redundant. So f over g, and when I look at this problem, I can't simplify fraction functions. At least you guys probably haven't learned yet how to simplify. But in this case, I'm looking at this problem and I can't actually simplify it either. So I have to go ahead and plug in my -3 in for x. So I'm going to go ahead and do that. So I've plugged in -3 in for my x. -3 squared is going to give me, I'm running out of room, so 9 plus 7 over -5. -3 minus 2 is -5. So then the top would end up being 16, and the bottom would be -5. And I can't reduce 16 over -5, so this is my final answer. Okay, so it is a bit of work, but it's not too bad if you can organize when you're simplifying. Okay, let's take a look at 21 next. So 21 is a composition function. Before I go into this, actually, let's look at, I think it's problem 25, and just recall what is the notation for composition functions. So anytime you have fog or f of g, this is saying that f is the outside function and g is the inside function. So if f comes first, it's the outside function. If g comes first, then it's the outside function, and now f is the inside function. So whatever comes first is the furthest outer layer, is how I think of it. So let's go back to that composition function. So for this problem here, 21, this is saying f is first, f of g, and then g is inside. So you can do it step by step, where you try to find the inside first and keep replacing until you're done replacing. So what I mean is, like, this inside is your g. You're going to replace it with what g represents. In this case, g was the, I think the x minus 2, if you look above. And then I have to plug x minus 2 in for f. So that's the x squared plus 7 equation. So I'm going to plug in x minus 2 in for x. So this is going to look like x minus 2 squared plus 7. So I plugged in the x minus 2 in for this x, and then I squared it. So I'm referring to the f function from the very beginning. All right, so now I'm just going to work this out. It does take a little bit of steps here because I have to FOIL the x minus 2 out. So I'll do that first. So that would give me x squared minus 2x plus 4 plus 7. So I FOILed all of this out, got the 4 terms here. I'm going to combine like terms, like these two combine and these two combine. So that would give me x squared minus 4x plus 11. And then that would be my final answer, because I can't combine any further. Okay, let's try a g of f1. So same thing, you're going to start by rewriting this. So g, plug in f, because g is the outer, or the first letter here. So that means that g is the outer layer and f is inside. So this time you're going to replace f with what it really is. So if you look back at what f is, it is the, let me bring it up. It is the x squared plus 7. And now what you're going to do is take your x squared plus 7 and plug it in for g. So you're going to plug all of this in for that x and then minus 2. So that's going to look like x squared plus 7 minus 2. And you're going to work this out. So notice that if I were to work it out, the 7 and the negative 2 are the only thing that combine. So I'm just going to bring down the x squared. And positive 7 minus 2 is positive 5. And I think that's it. That is my final answer because I can't simplify any further. All right, I think we have a couple more here. This one's an interesting problem. This one is f of f. So again, f is the one that comes first. So that means f is the outer layer. And then f again is the inner layer because another f came next. So first we're going to replace f of x with what it is. And that would have been, I think, x squared plus 7. And now you're going to replace the x squared plus 7, or sorry, you're going to plug the x squared plus 7 in for f. So if you look above, you have to plug it into this x here. So it's going to look kind of funny. Actually, you know what? I'll just rewrite the equation up here for myself so I can see, so I don't have to keep scrolling back and forth. So this is x squared plus 7, and you don't have to do this. I'm just doing it so I can see the equations. So again, I'm taking this and plugging in for this x. So that's going to look like x squared plus 7. And I would have to FOIL this out because it is a square. And I'm going to bring down the 7 that's next to it. So if I FOIL this out, x squared times x squared is x to the 4th. X squared times 7 is positive 7x squared. 7x times x squared is positive 7x squared. And that's going to be 49 if I multiply 7 with 7. And bring down the 7 that's to the side. So if I combine like terms, x to the 4th comes down. The two 7x squares combine to give you 14x squared. 49 plus 7 gives you 56. And so that there is my final answer because I can't combine it any further. Now, for the past 3 problems, notice that the problems only had x inside. So that's why you only had to find the simplified equation. Whereas this one here is a composition function where it's asking you to plug in 2. So in this composition function, you have to plug 2 in for g and then plug that number in for f. Now, I've already found what f of g is. Remember, f of g is just the fog equation that we've already accounted for. But let's pretend I haven't found that and I just got this problem. So if I wanted to find f of g, again, I would just solve for it. And then plug in -2. Or what I could do is find what g of -2 is first. So to the side here, g of -2. If I plug in, actually let me do that in the correct colors or else that might bother me. So I'll take g of -2 and figure out what that number is. So basically I'm plugging this -2 in for x and solving this out here. And that would give me -4. So what I'm going to do next is go back to the problem and plug in my -4 instead of the g -2. So think of this as like doing it in layers. So I've already figured out what g is. Now I'm going to plug -4 in for f. So I'm just going to take this -4, plug it into here. So if I work this out, this is going to be 16 plus 7, which gives me 23 if I add. And that there is my final answer. All right, so those were level 3 problems, all looking at composition and combination functions. We're going to move into level 4 problems, which is talking about even and odds and inverse functions. So going back to even and odd, things that you might need to remember if you look back at the review or previous journal, anytime you have an even, that means whether you plug in a positive number, it should have equal the same number if you plugged in a negative number. Whereas in odd, it's opposite. If you plug in a negative number, it will come out the same value but opposite signs. And so neither is just one of those cases where it doesn't fall into any of these 2 cases, so then it'd be neither. So we're going to try out these 3 problems to see what case they would be. So to do it, all you have to notice is like these are already the positive x versions. And so what we need to do is find the negative x version and then compare. So we're going to plug in negative x. and simplify and then compare the final results. So I'm going to go ahead and plug in negative x into all of the x's. And so in this case, remember to do your exponents first. So this is negative 6 to the 6th power. And so that would give me 2x to the 6th power. Because if you were to take anything to the 6th power, it would end up being a positive number. So that's why this x is positive. But it's still going to be 6 to the 6th power. Whereas this one is also even, and these are even. So they're all going to come out positive x's. So this will be x to the 4th, and this one will be x squared. And so when I look at these two, vice versa, they are the exact same equation. So this is probably an even function. So when you compare the positive version with the negative x version that you plugged in, they are identical. So because they're the same, we can say that this, let me write same. This is going to be an even. All right, let's check out our next one here. So again, they have the positive f of x. We're going to plug in the negative version. And work this out. So this is going to be 2 to the negative x cubed. If you took a negative and you cubed it an odd power, then this is going to come out as a negative x to the 3rd. This one here is a squared, but if you square a negative, it becomes a positive, so x squared. But there's a minus sign in front, so I did have to drag that down. But this here will be a positive x squared. Now these two, negative and 2, will come together, being negative 2x cubed. And so when I compare my final results, so I'm going to compare this guy with this, I notice that the first term is opposite signs and the same value, so they're both 2x cubed. But the second term are the same. They're not opposite signs. So the first term is opposite, but the second term isn't opposite. So that tells me that this is going to be neither because it doesn't fall under the category for even or odd. So this is going to be neither. So they're not the same, they're not opposite, so it's going to be neither. All right, so for 28, our last problem here, let me shift this over just a little bit. We're going to plug in, again, our negative x. And work this out. So this is going to be negative x to the 5th power plus 4x, because those two negatives will make a positive and the 4 will drop down. So when I compare these two, I notice that the first sign is opposite and the second sign is opposite, but all the terms are identical. So in this case, since the signs are opposite, this is going to be an odd case. And that's it. So you get to see 3 versions. Hopefully that helps you better understand which is which version. Let's talk about inverses. So inverse is one of our recent chapters. One of the things you'll need to know is how to find an inverse function if you're given an inverse or you're given an equation or a table. So to find an inverse, there are 3 steps to doing it. One, you need to switch your x and y value. That's probably the most important. And then solve for y. 3, this is kind of like one of those things, if you don't do it, it's not a big deal, but a lot of people will do it, is to replace the y that you get with f of negative 1. So let's get started with 30 here. So we're going to find the inverse of this equation following these steps. We're first going to probably replace this f of x with y. So if I were to think that as y, I would go ahead and switch the y and x's. So this would be, so if you have to write that out, that might help you. But then you would go ahead and switch the x and y's. And nothing else. After you get the y's and x switched, you want to try to get the y by itself. So you're going to move the piece that's usually further away from y until you have y by itself. So like this 3 here can be subtracted to both sides. And then I can divide -4 over. And so this is going to be y equals x minus 3 over -4. And then I can replace this y with the inverse f of x. So this is going to look like inverse of f x minus 3 over -4 as my final answer. You can also divide each of the coefficients by -4 and write it as a fraction. That's perfectly fine too. Or you just leave it like this. This one here, we're going to do the exact same thing. Again, I'm going to go ahead and switch my y's and x's. So this would look like x equals -y squared plus 4. And then I would subtract 4 to this side. So this would look like x minus 4 equals -x squared. I would then divide by a -1 to get rid of that negative. So I would divide this side by -1. And so that means that each one of these would get a negative. So that would be, if you think of this x as 1x, that would be like a negative x minus, but if this is a -4 divided by -1, that's going to give me a positive 4. Y squared comes down. And then when I look at this, I'm like, okay, I have to get rid of a square. So I'm going to take a square root. And so the square root and the square cancel. So I'm left with y equals the square root of -x plus 4. For this case, I'm just going to assume to take the positive. Because inverses don't like to have both positive and negative. It fails a 1-to-1 test. So for this, inverses just keep usually the positive. So the inverse of this function is equal to the square root of -x plus 4. And that there is my final answer. All right, let's take a look at this table here. So tables are nice. All you have to do is switch the x and y values when it comes to the table. But I like to make sure that my x's are in order from least to greatest. At least that's what it looks like on my key. It's not a big deal if you just switch it and not have them in order, but it's just my preference. So if I were to have my y's for my x's, the first one that would come up is -2. And -2 has a positive 3 associated to it. The next number would be 4, which has a -1 associated to it. And then 5 would be next, that has a 7. And so that's how I'd put in order, is make sure that the y's are where the x's are, and then make sure they have the corresponding y values. All right, for 33, our last problem, again, you want to switch the x and y's. So you have an equation here, so you have to switch the x and y's. So y is now inside the root. And to solve, you're going to need to bring the 5 over first, because it's the furthest thing away. So this is going to look like x plus 5 equals square root of y plus 1. You're going to need to get rid of a square root, so you have to square both sides to do that. So that would cancel, and this would give me y plus 1, x plus 5 squared. Now, because you're solving, do not try to FOIL this out. It makes it a lot messier. You only try to FOIL if it asks you to simplify. In this case, you just want to solve for y. So I'm going to move the 1 over by subtracting it to both sides. So I would have subtracted 1 from this side, and then I would have to subtract 1 on this side. So it's outside of the parentheses. And so now I have my inverse. So I'm going to call this f -1 is equal to x plus 5 squared minus 1 as my inverse equation. And that's it, guys. Hope this video helped you figure out the problems on this review. If you have any questions, feel free to ask me in office hours. Bye, guys.